We have some Googlers here on site. They came down just for us, along with all the equipment, which you may have seen out in the back near the restrooms. That again, we were competing with another GDG chapter on the East Coast, and we won. So yes. So we have Sandeep Dinesh here. Are you in charge of this Google Cloud Spin? We'll say he's in charge of it. This is his baby. And so he's going to talk about how this works and all sorts of other cool stuff. So take it away.
Cool. Mic, no mic. Mic?
Okay.
All right, that better? Yeah. All right, hopefully I don't trip over this. So, Google Cloud Spin, how to build that. Oh, really? All right, how do you build that, right? So that's what we're going to talk about. Let's start. All right, so my name is Sandeep. As Matt said, I am a developer advocate at Google out of the San Francisco office, so it was not too big of a flight down here. And so this is the story of Cloud Spin, or how we got all matrixy in the cloud. So the idea was, as developer advocates, we do a lot of hello world type stuff and helping people start building stuff on the cloud. We never build anything cool and spectacular and big. So we said, what if you're the CEO of a fake startup and your goal wasn't to make revenue, but instead to make cool products? I hope that if you're actually a CEO, your goal is to make revenue. But our goal was to make a cool product, right? So we said, all right, we're a startup. We have 3 weeks to come out with the MVP, and it has to work. So in 3 weeks, we had to build something that you see in the back corner today. And this is an interactive talk, so stop me anytime if you have questions. So what it comes out with, as you've seen before, is a GIF that looks something like this. This is with our 19-phone rig that we use in our bigger events that we can set up beforehand. And it looks pretty cool. Now the question is, how did we do this in 3 weeks? So Cloud Spin, pretty simple stuff. You have a bunch of phones in a 180-degree arc around the subject, who's a smiley face. Smiley face is very important. You might jump, like this is what marketing came up with way too much budget. And the little guy with the suitcase stands in the middle. We say 3, 2, 1, jump. He jumps up. All the phones take a picture somehow, and you get that GIF. But it's kind of tricky. It's not that simple, right? I made it sound really easy to do, but once we started working on this, we're like, wow, okay, this is actually kind of hard. Question, so how would you do it? I should not touch that cable. How would you guys do it, right? If you had to build this in 3 weeks, where would you start? So this is what we kind of ended up doing. We needed to record a video. And why do we need to do that? We were using completely off-the-shelf Android phones, right? And if you say Android phone, take a picture to 19 different phones, the pictures are going to come out at slightly different times, and it's going to look terrible. So instead, we said, wait, videos are 30 FPS. We can just take a video and then extract a frame out of it. That's easy, right? But how do we identify the frame? And how do we mark that frame? So we try to use timestamps and flashes, and a lot of them didn't really work out. So what we ended up doing was using an audio marker. So what is that? The video has 2 parts, the picture and the audio, so it's built right into the video stream, which is really easy for us to use. And first challenge, who has tried to use iPhone headphones on an Android phone or vice versa and had problems? Okay. If you don't know, the microphone and the ground are flipped, which means that sometimes it works and sometimes it doesn't, right? So we had to go and build our own custom rig. So we said, okay, here's the electronics. Let's take an audio signal, flip it around into the microphone signal, and dump it into all the phones. And this is what we built first. That is not scalable. That's a bunch of resistors trying to feed one audio signal into 19 different phones. You disrupt one of those little things and it just completely breaks. Yeah, not something you want to travel with. So, it wasn't the best, but it started working. So we said, can we do something even more off the shelf? And the answer was yes. So we took off the shelf audio splitters and amps and stuck them all together and fed them all into the different phones. And so you have one tablet, and you click go, and it sends an audio signal to every single phone to mark that frame. All right, so now you have video on every single phone with a little beep. And let's see how that sounds. All right, I will do that one more time. I'll put the microphone right here. I'm not sure if anyone can hear that.
Yes.
But you guys can hear that little beep?
Yes.
So that's what's marking each frame. Now you have all these phones, and you have all those frames that are marked. Extract the frame, make the GIF, right? Sounds easy. And it actually is pretty easy, because we have Google Cloud. Haha. So, how do we do this? You must memorize this in the next 5 seconds, because there'll be a test. No, I'm just kidding. So this is kind of the architecture that we came up with to do all of this processing, right? We got all these videos, we got to do something with it. I have a clicker, all right. So we have input buckets, notification processors, extractors, and stitchers, all of these things working together to give you that final output of our beautiful GIF. All right, so let's go through in detail on how we actually did this. And please stop me at any time when you have questions. So the question is, how do we coordinate all 19 cameras? In the back we have, yes, question.
You just spoke about that. You told you made a resistor, a connection of resistors. What was that for? I missed that.
It was basically to take one audio signal and then send out 19 microphone signals.
Where is it being used in this?
It's not being used anymore.
Oh.
Yeah, we're using off-the-shelf audio equipment now.
Okay, earlier you used to use that to...
That was the first prototype, long time ago. All right, so the question is, how do we coordinate 19 phone cameras, right? We have to tell each phone to take a video. We have to tell each phone where to upload the video, who it's for, things like that, right? But seriously, you have to do this in real time, right? Every single phone has to start taking the video, uploading the video, coordinating, being ready, giving it status back and forth, all that stuff. So, drum roll please, we used all these things. Camera app status and error messages. That needs to be real time, otherwise we can't debug this. The ISO and shutter speed. That has to be the same for every single phone. Internal versus external microphone. We don't want the internal microphone on the phone to be triggered. We want the audio input to be used. And of course, the timestamp to start the recording. So for all this, we use something called Firebase. How many of you have heard of Firebase in the audience? All right, good. Good. Firebase is super cool. If you have not heard about it, you can think of it like a real-time JSON object in the cloud, right? So it's a giant JSON object that all your devices share, and every time a device changes one of the values, all the other devices get that same change in real time. So it feels like a local memory object, but it's in the cloud, which is really, really cool. So this stores our data in cloud, really fast updates. It's perfect for what we're trying to do. All right, so here is some Android code on how it was used. So we see that we have a reference to our Firebase that is kind of connecting to our database. We get all the camera status information from Firebase. Then we set all our camera information, right? I'm phone number 5. I am ready. We're good to go. And then all 10 phones, all 19 phones, all send that same status information. And then we get a cool little admin view on our tablet. So all our phones are ready, and then we can click Start Countdown. Once we click Start Countdown, we write a timestamp into Firebase. And now all the phones get that instantaneously, and they say, okay, I'm going to start recording now. And then they start recording. So that is cool. Super easy to do. So timestamp. All right. So now we have all the phones actually recording the video. They have to upload it somewhere, right? Each phone is recording 10 megs per snap. So with the 20 phone rig, it's about 200 megs per picture. That's a lot of data once you start taking a ton of pictures, right? That's also why the Wi-Fi is very important. So what do we want to do? We want to upload them all into some sort of bucket and then process it once it's uploaded. So what are requirements? We had to store a large amount of unstructured data. We can run this all around the world with thousands of rigs, and they all have to upload data, terabytes and terabytes eventually. And we also need immediate access. Once the data is uploaded, we need to be able to download it immediately, right? Otherwise, more lag, which is bad. And it would be really, really nice if every time a new object was uploaded, we get a notification of some sort saying this is ready, right? Otherwise, we'd have to keep polling the system, which, again, causes more performance issues. luckily, in Google Cloud Storage came to the rescue. So Google Cloud Storage, for those of you who don't know, is our object storage platform. So you can store up to terabytes per object, which is great for video. It gives you a 99.9 SLA, and it's geo-redundant, and it's replicated, and all those good things that you expect in a cloud storage provider. But the cool thing here is it also has something called change notifications. And what change notifications are is every time an object is uploaded or changed, we'll see the actual JSON soon, it is giving you a notification on what happened. Just a little bit more details. There are currently 3 types of cloud storage. We use standard storage, which has the highest speed, availability, and durability, and a slightly higher cost. We also have durable reduced availability storage, to say that 3 times fast. Basically, it means that if you don't need it immediately, it'll be there, and you might take a little bit of time for you to get it. And then we have Nearline. And Nearline is our cold storage product. You can basically store tons of data for a very low price and still access it pretty frequently compared to something like tape. It's like 3 seconds for it to spin up, which is really fast. Okay, so now we have all those things uploaded into our storage bucket. Once it's uploaded, we get a little webhook that triggers, and it sends us a little notification. So boom, boom, right? So we get a new video, and then we get a notification. What does the notification look like? It's a simple JSON object. These are standards-based stuff, and we can say all the information that we need to start uploading that video. To start processing that video. All right, so again, some little bit of Android code and how we did this. We get an input, that does not work. We get an input file upload stream, right? So we're streaming that video to the cloud. Once it's recorded, we call it video MP4. We put some metadata on it, and we send it up to the cloud. And then we close the stream. Very easy stuff. All right, cool. So one other really cool thing about Google Cloud Storage is it automatically edge caches your data, right? So you don't need to use a CDN or anything like that to get the automatic benefits of caching. So we have all these data centers all over the world because Google, and if you have a lot of users in, say, South America who are using Cloud Spin, it'll automatically cache all those images and videos down there. If you have a lot of people in Europe, it'll cache it up there, and it's automatically done for you, which is nice. All right. So, next step, notification processing. So now we have those notifications coming in. We got to do something with it, right? What do we want? We want to be able to handle those HTTP post requests, some simple authentication, and we want to be able to process those tasks and push them onto a queue so we can start actually consuming them and doing stuff with those videos. And for this, we wanted something really easy to use, so we chose Google App Engine. How many of you have used App Engine before? All right, some of you. You might know that it's our platform as a service, which means you write code, click deploy, and it works for the most part. We have Java, Python, Go, and PHP. And you can also run custom runtimes in Docker, which is really nice. The cool thing is it's fully managed and it's operated by Google SREs, so you don't have to worry about uptime. As long as your code works, we will scale it for you and we'll make sure that it's always running. So no matter how much traffic you get, we will scale to meet that load. All right. So now we have that basically taking in those JSON objects that we saw coming from cloud storage and doing something with it. And what exactly is it going to do? So let's look at messaging, right? So Cloud Spin is going to get really popular. We have so many people in New York, in San Francisco, in Tokyo, all using Cloud Spin. And all of a sudden, our app starts to get more and more and more traffic, right? How do we kind of deal with this? So we need some sort of messaging system, some sort of queue to buffer these messages out so we can process them without dropping jobs, right? So messaging really is a shock absorber. It gives you availability, lets you buffer those requests, so preventing outages. Let's say for some reason we just decided to shut down our cluster. As long as we had our messaging coming in, we could buffer those requests and it can spin it back up, and we don't lose any of the customer's information, right? It also helps us with throughput. If we had to scale immediately for every single request, that's too crazy. Instead, we can buffer your messages and scale up to meet that, and then scale down when necessary. So we save a lot of money on not having a huge cluster running all the time. All right, so this is what it kind of looks like, right? So we have extractors and we have stitchers. And we're going to tell them that there's some work for them to do. So let's see how we do that. We need something that has asynchronous messaging. We have tons of these people all over the world using our product. We can't wait for one to finish. We need a lot of different workers all pulling from the same time. Pull subscriptions, we need those. So what's the difference between a push and a pull subscription? A push subscription will just push a message out to the worker itself. A pull subscription, you pull on the queue, and every time there's a new message, it'll push and then you act back. It's very pretty similar. We're using pull subscriptions because they're more versatile, and I'll explain that in a second. So we are using Cloud PubSub. This is the same messaging system that powers most of Google. It's very, very, very similar. When we say it's designed for Google scale, Google has almost 10 to the 10th RPCs per second in our data center. 10 to the 10th. That is like mind-bogglingly huge number. So it's really designed for high availability and high throughput. And because it's running all on Google's fiber inside our data centers, it's really, really fast. So let's pretend that is our queue. We can have different publishers. In this case, it is our App Engine app throwing those notifications onto that queue. Multiple topics, and we can have multiple subscribers per topic, right? And then for each subscriber, we can have multiple workers. So a subscriber kind of duplicates the message for each subscriber. So if you have 10 subscriptions, that message will be duplicated 10 times. And then each worker for each subscription will consume those messages, right? So for our extractors, we have 1 subscription and 10 workers. And then for our stitcher, we have 1 subscription and 1 worker. So who can push and pull to a PubSub topic? Anyone, really. Anyone who can do OAuth. So we can have desktop and mobile apps, cloud platform stuff, other clouds, JavaScript, HTML5, all those good things. And then who can pull? Again, anyone who can do OAuth to our cloud. So again, same people, which is great. So this is again what we're doing. Our App Engine app is pushing all of those videos to be extracted onto our queue, and then we have extractors spinning up and extracting those frames from the video. All right. So now I put my evil voice on. Meanwhile, in our secret startup lab, our first prototype was, wait, what? Cheap and scrappy. Like really scrappy. So yeah, we had no measuring tape, so caution tape works too. Selfie sticks are not, they don't balance. Just don't do this at home. Yeah, you will break phones. And eventually, we upgraded to tripods that you can see in the back. Of course, Google intern, first challenge, how do you plug in a light? That's why he's really thinking hard why that's not working. Poor guy. All right, so that's cool, right? Now we're getting these videos up, pushing to a PubSubQ. Things are starting to look good. We have these things in the cloud now. Let's see what we can do to extract those frames out. So we have the extractor and the stitcher. And you might notice something here, right? This is the audio signal from each video. There's one thing that sticks out. It's that, right? Obviously. So very easily we can use amplitude to just pull that frame out. Of course, we can use FFTs and stuff to kind of clean up noise, but we didn't have to do any of that. We just saw what is the highest amplitude using some mean and standard deviation calculations, and then we can mark our frame. So here's some Python code. Again, you have to memorize this because there's a test in the end. But we're using MoviePy, which is a cool Python movie library. And all we're doing is extracting the audio, bucketing it into frames, and then finding the frame that has the highest amplitude. And then we get our number. So now each of our videos has that frame extracted out. But how do we do this, right? How do we run our workers to actually extract those frames? We can't just run a bazillion copies of this and just hope it works. That'll cost way too much money. So we want a long-running service with on-demand scaling of workers based on queue depth. We also want to be able to act as a PubSub subscriber, but as we heard, that's not that hard to do. And we also want it to be simple to develop. Remember, we only did this in 3 weeks, and that's a real thing. It only took 3 weeks to build this. So what we ended up using is Google Compute Engine. Basically, it's our VMs as a service. Infrastructure as a service is another way to say it. And what you can see is we have a few advantages why we like Compute Engine. First is sub-hour billing. We only bill you per minute that you use, not per hour. So something like Cloud Spin, where it can scale up and down, each minute does count. We have fast networking again because it's all in the Google data center. And our VMs spin up ridiculously fast, like 30 seconds per VM. So you can spin up 100 VMs in 30 seconds, which is crazy. All right, so in the olden days, how you'd build this, right, is you'd pick a giant on-metal, like on-prem machine, bare metal, and run all your apps on it directly. So what's the problem with this, right? All your apps are very tightly configured with the operating system. It's very hard to upgrade things. Things break. You go from Java version 7 to 8 and everything stops working, right? You guys all know these nightmares. Luckily, we had virtual machines. And the cool thing here is it offers a lot of